Assalamualaikum and good day. Welcome to Operation Management class. In this class, I will talk about Chapter 6S, Statistical Process Control. When you complete this chapter, you should be able to first explain the purpose of a control chart. Second, explain the rule of the central limit theorem in statistical process control. First, let us understand what is SPC. Statistical process control, also known as SPC, a process used to monitor standards by taking measurements and corrective action as a product and service is being produced. A process is said to be operating in statistical control when the only source of variation is common causes. The process must first be brought into statistical control by detecting and eliminating special causes of variation. Then its performance is predictable and its ability to meet customer expectation can be assessed. The objective of a process control system is to provide a statistical signal when assignable causes of variation are present. Such a signal can quicken appropriate action to eliminate assignable causes. We know that inside process is going to be variation. It could be natural variations or assignable variation. Natural variations affect almost every process and are to be expected. It also known as common cause. Natural variations form a pattern that can be described as distribution. Assignable variation is a process can be traced to a specific reason. Natural and assignable variations distinguish two tasks for the operation manager. Natural variation is to ensure that the process is capable of operating under control with only natural variation. Assignable variation is to identify and eliminate assignable variation so that the process will be remain under control. Figure S6.1 provides a detailed look at the important steps in determining process variation. The horizontal scale can be weight or length of any physical measure. The vertical scale is frequency. I will briefly describe each process. At A stage, the samples of 5 boxes of cereal are weighted. At stage B, the sample of 5 boxes of cereal form a distribution. The distribution formed in B will fall in a predictable pattern. At stage C, The samples of 5 boxes of cereal can vary. The distribution form in C will fall in a predictable pattern. The distribution form in a predicted pattern at stage D if only natural variation is present. If assignable causes of variation are present, then we can expect either the mean to vary or the distribution to vary. State E will get a similar result as stage D. Distributions form in a predicted pattern if only natural variation is present. If assignable causes of variation are present, then we expect either the mean to vary or the dispersion to vary. In statistical process control, we are trying to do is to determine whether the variation is natural or due some sort of cause that we're going to have to correct. For this, we use control charts, which is a graphical presentation of process data over time with predetermined control limits. So, when the variation exceeds the control limits, there is a problem. However, if the variation goes below or lower level limits, there is not a problem. This situation is very easy to see on the graph. The variables of interest here are those that have continuous dimensions. They have an infinite number of possibilities. Examples are weight, speed, length, or strength. Contour charts for the means, x-bar, and the range r are used to monitor processes that have continuous dimensions. Here, let us take a look at control charts for variables. The variables of interest here are those that have continuous dimensions. They have an infinite number of possibilities. Examples are weight, speed, length, or strength. Contour charts for the means or x-bar and the range or r are used to monitor processes that have continuous dimensions. The x-charts tell us whether changes have occurred in the central tendency of a process. These changes might be due to such factors as tool wear, a gradual increase in temperature, a different method used on the second shift, or new and stronger materials. The R-chart values indicate that a gain or loss in dispersion has occurred. Such a change may be due to worn bearings, a loose tool, an erratic flow of lubricants to a machine, or to sloppiness on the part of a machine operator. The X-bar chart and R-chart go hand in hand when monitoring variables because they measure the two critical parameters, central tendency and dispersion. The theoretical foundation for X-bar charts is the central limit theorem. This theorem states that regardless of the distribution of the population, the mean of the sampling distribution will be the same as the population mean. And the standard deviation of the sampling distribution will equal the population standard deviation divided by the square root of the sample size. Defining control limits. Let's say you have a population. We can take sample of the population, get the means of those samples that tends toward a sampling distribution of the means. That was somehow in what we are looking in a normal distribution. So we use that when we set up our control limits. Here we have our normal distribution. It's a nice bell curve. And if we are trying to capture a natural variation as possible, in the most cases we define the control limits to be 3 standard deviations above the mean and 3 standard deviations below the means. That means we capture 99.73% of all the area natural variation that in the process. So something fall outside of those limits, we pretty sure is it due to assignable cause. Let us take a look at the control chart. Here we capture means of sample over time. There is lot of variation there. But right now, we cannot tell whether the variation are normal or the variation is due to a particular causes. So now we added the normal distribution there. We can see where that normal distribution spread. If we take 3 standard deviations are above the mean and 3 standard deviations below the means, we know the upper and lower control limits. Now we can see that most of the variations which actually fall inside the control limits. So that were natural variations, but we also has one point which is outside the control limits. This is what we have to look for, the assignable variation. Because it is now beyond the 3 standard deviations that are away from the mean, it most probably due to external cause. So that is what we generally do with control chart. After finishing this chapter, you will be able to understand the purpose of a control chart, understand the rule of the central limit theorem in SPC. Thank you.